Welcome back. We'll be covering the topic of time, speed, and distance in this lecture, and we'll be done with the part of arithmetic. So, let's understand what is the relationship between time, speed, and distance. As we already know, speed is given as distance traveled per unit time. So if you have the value of distance traveled and time, and if you divide them, what you end up with is your speed. So speed is distance traveled per unit time. That means in a unit time, how much is the distance that you can travel? If I just cross multiply the things, I'll be able to get the formula for distance. Now, distance traveled is speed into time. If I know the speed, that means how much is the distance that I can travel per unit time into time would give me the value of the distance that I have traveled in total. Now, if I talk about the units, the distance would be given in terms of miles, whereas the time would be in terms of hours. So the general units, the other units for distance could be, in terms of feet, it could be in terms of meters or kilometers. Time could be in terms of seconds or in terms of minutes. Again, it depends upon the question. So if I talk about the units in the second formula, they'll turn out to be, if my speed is given in miles per hour, I'll take my time in hours so that the distance traveled that I get would be in terms of miles. Let's look at an example. Lamont traveled 80 miles in 2.5 hours at a constant rate. He then decreased his speed by 25% and traveled 120 additional miles at a new constant rate. Now, if you look here, this additional miles have been traveled at a lower rate. So, if I have to travel a constant distance at a lower speed, the time that I would require would be on a higher side. You take an example from your office or school or college, whatever, it is, you are going to your home. So the distance between your home and your office is kind of fixed. Now, if you increase your speed, you'll reach early. If you decrease your speed, you'll take a longer time to travel the same distance. So, what I'm doing is, if I am decreasing the speed, the time that I'll take would be a longer time. Now, the question is asking me how many hours did it take for the entire journey. So let's look at the solution for this. I know that the initial speed of Lamont is distance divided by time would give you your speed. Distance per unit time would give you your speed. So the initial speed is 32 miles per hour. Now his speed is reduced by 25%. That means 25%, if you can convert, 1/4. 1/4 of the speed is reduced. So that means if reduction is 1/4, I'm left with 3/4 of the initial speed. One is this way that I can, travel, then I can solve the question. Or what I can do is I can just subtract 25% of 32 from 32 to get to an answer of 24 miles an hour. So this is the new speed. Now, if I have to calculate the time would be distance by speed. So the additional time taken is the distance which is traveled, which is 120 kilometers, divided by the speed, which is 24 miles per hour, giving me a time taken to cover this distance as 5 hours. So the total time taken for the entire journey would be 2.5 hours are taken initially when I was traveling at a speed of 32, and 5 hours is taken when I'm traveling at a speed of 24. So the total time which is taken is 7.5 hours from the beginning. Let's look at some other questions related to time, speed and distance. It's a simple formula, which is distance is equal to speed into time, which will be used in almost all the questions. A car got 33 miles per gallon using gasoline that cost 2.95 per gallon. Approximately, what was the cost in dollars of the gasoline used while driving the car 350 miles? And if you look at the question very, very carefully, it is asking you approximately. So if you look at the answer options also, they are all close to the multiples of 10. So if I just look at the question, cost of 1 gallon is 2.95, and in 1 gallon I can travel 33 miles. So in order to travel 33 miles, I will take $2.95, or I should say $2.95 is spent. To travel 1 mile, the amount that would have been spent will be 2.95 over 33. And in order to travel 350 miles, the amount that would be spent would be 2.95 over 33 is the cost per mile into 350 is what you need to calculate. So if you have calculators available with you, what you can do is you can just simply multiply the things at this point of time using the calculators, get to an answer which is coming out to be 31.28, and you need an answer which is approximately. So if I just round it off, the answer that would match would be option number C. However, if calculator is not available to you, you can just approximate the thing. You can say this is 3 and this is 33 and this is 350. So this can be cancelled with 11. Now if you just divide 350 with 11, the answer that you'll end up would be again 31.8. So you know your answer has to be a little lesser than that. So the answer which is missing is option number C. Another question that we have is, convert 6 miles per hour into feet per second. So if you look at the speed that you have is distance traveled per unit time. So this will be distance traveled over time taken. So if I just look at it, distance here is 6 miles and time which is there is 1 hour. So I just need to convert the thing. 6 mile, if you look at it, the conversion is already given to you. 1 mile is 5280 feet. So 6 miles will be 6 into 5280 feet. And I need it in per second. So I just need to convert hour also into second. 1 hour has 60 minutes and each minute has 60 seconds. So 1 hour has 3600 seconds. So what I just need is, I just need to calculate the things using a calculator if available to me. If it is not available to me, I'll simply do a little bit of approximation and get to my answer. So if you solve it out, the answer that you're getting is 8.8 feet per second. This is how you convert one unit into another. The third question that we have is, in a driving competition, Jeff and Dennis drove the same course. Now this is very, very important. Same course means that the distance traveled by both of them is same, or I will say is constant, at an average speed of 51 and 54 miles per hour. If Jeff took 40 minutes to drive the course, how long would Dennis take? So if I just look at the thing, if I look at that, distance is equal to speed into time. If I look for Jeff and Dennis separately, distance traveled by Jeff will be equal to speed of Jeff into time taken by Jeff, and distance traveled by Dennis will be equal to speed of Dennis and time taken by Dennis. But if you look here, the distance that Dennis and Jeff are traveling is exactly the same. So I'll get S1 into T1 is equal to S2 into T2. Or what I can write is, their speeds are inversely proportional to their time taken. The greater the speed, the lesser will be the time taken. The lesser the speed, greater will be the time taken, provided your distance is constant. Now if I look here, 51 and 54, this has a higher speed, so it will take a lesser time. My answer should be less than 40. If I look at all the answer options are less than 40. Good choice for answer options. So if I just look here, I put in the values. 51 and 54 would be equal to time taken by the second one, which is Dennis, over time taken by Jeff. So if I talk here, I'm taking 40 minutes. This also I'll get it in minutes because it's the ratio. The ratio is a unitless quantity. So I need not worry that what are the units on the left hand side or the right hand side, because both the quantities are unitless. So again, using the calculator which is given to me, if I just find out the value of T2, it comes out to be 37.8 minutes, which is answer option C. So it'll take a little lesser time. How much lesser? It'll take around 2.2 minutes more, sorry, 2.2 minutes less than Jeff to travel the same course. Let's look at question number 4. Running a 10-mile loop in the same direction, Sue ran at a constant rate of 8 miles per hour. Okay, so I have the speed for Sue, which is 8 miles per hour. And Rob ran at a speed for Rob. Rob ran at a constant rate of 6 miles an hour again. If they began running at the same point on the loop, how many hours later did Sue complete exactly one more lap than Rob? That means after how much time Sue and Rob are at the same point such that the distance traveled by Sue is one more than the distance traveled by Rob. The total distance traveled by Sue from the beginning is one lap more. So what I can do is I can start with the answer options. I will always start with the middle value. So if I talk about 5 hours. Now, my speed for Sue is 8 miles per hour. So in 5 hours, it would have covered 40 miles. 40 mile means 10 mile loop, it would have covered 4 rounds. Now, if I talk about the other one, which is Rob. Rob has a speed of 6 miles per hour. Right. So in 5 hours, it would have done 6 into 5, which is 30 miles. That means it would have done 3 rounds. Now if I look here, Sue is 1 round ahead of Rob, which was the answer that I require. So my answer option would be option number 3. Simple enough, you just plug in the values and you will get your answer. Always start with the middle value. If that does not work, you will move to either left or right. Now, the another concept that we have is the concept of average speed. Average speed is given by total distance traveled over total time taken. So, whatever is the total distance that I have covered and whatever is the total time that has been taken to cover that much distance is what gives you average speed. Let's look at an example. Paul drives from his apartment to his parents' house at an average speed of 60 miles per hour and backs along the same route with an average speed of 80 miles per hour. What would be Paul's average speed in miles per hour for the round trip? Now, if you look at the speeds which are anyways given to me, and if I use that speed to find out the average. Now, the speed in the onward journey is given to me as 60 and in the return journey is given to me as 80. So, if I find out the average of 60 and 80, it comes out to be 70. However, this is a wrong way to calculate the average speed. Average speed cannot be calculated by just taking the simple average of the averages which are given to you. The correct method is follow the formula, which is total distance traveled over total time taken. Distance traveled over total time taken, it will be d in the forward and d in the backward divided by d by 860 plus d by 80. Solving it up gives me an answer of 68.6, which is the correct answer that we have. There are certain special cases that I need to keep in mind whenever I am solving a question of average speed. Case 1, if the distance covered are same, which was the case in the previous case, he was going from his house to his parents' house and again coming back. An average speed will not be given by simple average of the speeds which are given to me. Average speed will be given by 2 S1 S2 over S1 plus S2. Whereas S1 is the speed in the first leg of the journey and s2 is the speed in the second leg of the journey. The second case that we need to remember is if time spent are equal. Now, if time is same, if I've spent the same amount of time on both the speeds, then the average speed would be given as the simple average, which is s1 plus s2 by 2. This would give me my answer for average speed. Let's look at some of the questions for average speed. Roger took 2 hours to walk from his home to a store 3 miles away and then returned home along the same path. So what are we talking about? We are talking about the case where distance is constant. Now if you remember the formula would be 2s1 s2 over s1 plus s2. If Roger's average rate for the round trip was 2 miles per hour, at what rate in miles per hour did Roger return home? So what is it? The total average thing is given to me. Right, the total average thing is given to me as 2 miles per hour. For the forward trip, 2 hours to walk 3 miles away. So distance over speed. The speed is 1.5 miles per hour. I have to find what is the speed in the return journey. So the average is 2 meters per hour. Now if I look at it, my average is always between the highest and the lowest. So it is average is greater than 1.5. So that means this S2 has to be greater than 2. S2 cannot be equal to 2. So that means this option and this option are anyways eliminated. So if I have to solve it out, I'll solve it out with 2 into S1 into S2 over S1 plus S2 is equal to your average speed that you have. So if you just solve the question, that is it that you have. So this is 1.5 S2 is equal to 1.5 plus S2. Now whatever is the thing that you have, you can just see which value would come up to be. So if you just bring this thing up, it is 0.5 S2 is equal to 1.5 or S2 is equal to 1.5 divided by 0.5. So if you just look at it, your answer turns out to be 3. This is the value that we have for the return journey average speed. The next question that we have is, Jack traveled the first 75% of an 80-mile trip at 45 miles per hour and the remainder at 30 miles per hour. What was Jack's average speed for the entire 80-mile trip in miles per hour? Now, if I just look at this question that we have, in this question there is nothing like, same distance or same time. So nothing is same. I'll just follow the formula that average speed is given by total distance traveled. What is the total distance? It is 80-mile trip. 80 divided by total time taken. Time depends upon speed and distance. So the initial distance which was there was 75% of 80. This much distance I've traveled at 45 plus the leftover distance, which is 25% of 80, 1/4 of 80 would be traveled at 30. So if I just look at it, this will be 80. So this will be 3/4 of 80. So which will be how much? Which will be 60 over 45 plus 1/4 of 80, which is 20 over 30. So what you can do is you can take your LCMs here and you can solve the question. So if I just look at it, this is 80, 6 and 3. So the answer that I end up with is 40. 40 is the average speed for the entire trip. The next concept that we have is the concept of efficiency. Efficiency, also termed as the rate of doing work and expressed as work done per unit time. So how much is the work that you do in a unit time is what your efficiency is. A better efficient person will be able to do more work in the same time as compared to the other person. So if I just look at it, if Raja and Rena can do a job in 10 days and 15 days independently, how many days would they require to complete the same job working simultaneously? So if you look at it, I would look at the efficiency of Raja first. Raja is completing a job in 10 days. So if I assume the total work which is done is W can be finished in 10 days. So that means the efficiency of Raja is work done, which is whatever is the work done, W, divided by time taken, which is 10 days. Efficiency of Reena is work done divided by time taken, which is work divided by 15. So now when they both are working together or they are working simultaneously, both of them will do their part of the job. They'll not interfere in each other's job. So efficiency of Raja and Reena together would come out to be W by 10 plus W by 15. This is the efficiency that they work out when they are working together. And this efficiency is equal to, again, W over time. So that means when they are working collectively, I can just eliminate the value of W because work is same in all the three cases. I'll be just left with the equation 1 by 10 plus 1 by 15 is equal to 1 by t. So the time taken together while solving this equation would come out to be 6 days. So when they are working together, they'll take only 6 days for the work to be completely done. There is certain important concept that I need to keep in mind whenever I'm doing a question based upon efficiency. If A can complete a work in 10 days, then in 1 day, A will be able to do 1/10 of the total work. So if I'm taking 10 days to complete a work, every day I'll be doing 1/10 of the job. If the efficiency of A is twice that of B, then in a given amount of time, A will be able to do double the work as compared to B. So if A and B are not equally efficient, A is more efficient than B. In the same amount of time, A will be able to do double the work as compared to B. So work done will be in the ratio 2:1. And if by chance I have to do the same amount of work has to be completed, then A, whose efficiency is actually higher, would take half the time as compared to that taken by B. So the time taken would be in the ratio 1:2. Another question that we have related to the same concept is, working alone at a constant rate, machine A produces K carbots in 10 minutes. Working alone at a constant rate, machine B produces K carbots in 15 minutes. How many minutes does the take machine A and B working simultaneously at their respective constant rate to produce K car parts? So again, if I have to look this question, I would look at the work done per unit time. K car parts are produced in 10 minutes. So per minute, this is the time that they spend. K cars are produced in 15 minutes. This is the time that they spend. When they are working together, K car bars are done in T. So this is the T that I need to find out. Now important thing is this T would be between 10 and 15. So I can just cancel the things with K. I am giving you 1 minute to solve the question. You can use your calculators to solve the question in case you want. So the value of K comes out to be 6. 6 minutes is the time taken to produce K car parts. The next question that we have is, working alone at their respective constant rate, Audrey can complete a certain job in 4 hours while Ferris can do the same job in 3 hours. Audrey and Ferris worked together on the job and completed it in 2 hours. But while Audrey worked this entire time, Ferris worked for some time and took total of 3 breaks of equal length. How many minutes long was each of Ferris' break? So now look at it. Let the work done be W. Now, Audrey can finish it in 4 hours. So what is the efficiency? W by 4. Ferris can finish it in 3 hours. So Ferris efficiency is this. Now when they are working together, everybody will do their part of the job, and if you just solve it out, this is what it comes out to be. So this is equal to work done divided by the total time which is taken by them collectively. So the total time which is taken by them collectively is 12 by 7 hours. If I just solve 12 by 7, I would get an answer which is equal to 1.714 hours. This is the time which is spent. Now, Ferris has completed it in 2 hours. So that means they're taking more time to finish this thing off. So if I just look at the difference between 2 and 1.714 hours, it comes out to be close to around 0.2857 hours. Now this 0.2857 hours would be converted into minutes, because this will be the answer that I want is in minutes. So in terms of minutes, it's coming out to be 17.142 minutes. This will be the time to, extra time which is Ferris is taking. Now this time is divided over 3 breaks. So per break would come out to be, if I just divide it with 3, per break would come out to be 5.714. So how many minutes? It will be approximately 5 minutes. The next concept that we have is the concept of chain rule. Very, very important thing that is being told in this thing. That is, the ratio of input over output under all the situations remains constant. So if you fill in your values of input and output correctly, you will get your answer in less than 30 seconds for a question related to chain rule. So input 1 over output 1 is equal to input 2 over output 2. Let's look at a question. 12 workers pack boxes at a constant rate of 60 boxes in 9 minutes. How many minutes would it take for 27 workers to pack 180 boxes if all the workers work at the same rate? Now, look at it. What is input and what is output? Now, this box, whatever I'm doing, I'm putting in hours, minutes, times, workers. They are all input. What I get in output is my boxes. So, this is my output 1. 9 minutes. That means 9 minutes is the input that I'm putting. How many minutes would it take for 27 workers? It is getting again 12 workers. This is again an input in the first case. 27 workers, input in the second case. 180 boxes needs to be packed. That means the output in the second case if all the workers worked at the same constant rate. So what is the input in the first case? It is 12 workers and they are wasting 9 minutes. And what is the output? 60 boxes. Should be equal to 27 workers and they are working in some time divided by the output that I am getting is 180 boxes. So if you look at it, this is 3 times that I have. Again, I can just cancel out the unwanted things, and the time which is taken in the second case would come out to be 12 minutes. Let's look at another question related to chain rule. Last year, a magazine charged $50 as subscription fees. This year, the price will be increased by $10. If the magazine could lose 4 subscribers this year and still collect the same revenue as it did last year, how many subscribers did the magazine have the last year? So this is the question that we have. If I follow the chain rule and if I look at it, the input would be the number of subscribers that you have, the number of subscribers and the subscription fees. That means how much is the money that I am getting from each subscriber into the number of subscribers will be your input, and which is actually equal to your revenue. Now revenue in both the cases turns out to be same. That means output turns out to be same. So that means the product of the inputs should also be the same. So what you have is number of subscribers in the first case into subscription fees in the first case would be equal to number of subscribers in the second case and subscription fee in the second case. So I had $50 subscription fees in the first place into the number of people that I had was, let me call it as N1. Now in the second case I am losing 4, the number of people that I have is N1 minus 4 into 60, because 60 is the money that I have in the second. It's a subscription fee that I charge in the second case. So the equation that I get is 5N1 equal to 6N1 minus 24. I can just solve this thing. So if I just take 24 here, 6 minus 5, the value of N1, that means the number of people in the first case that I have subscribed were 24, giving me an option E as my correct answer. Thank you so much for watching the videos based upon the arithmetic topic. We've completed arithmetic today, and you can like us and subscribe us on our YouTube channel to get more videos on the related topics of algebra and geometry. Like us and follow us on Facebook and Twitter to get regular updates. And you can visit our website edusati.com to practice more questions on this and other related topics. Thank you so much for watching the video. Have a great day and all the very best for all your preparations.